Okay, so today we are going to be solving systems using what we call elimination. Okay, it is the third and final method for solving systems of linear equations. All right, so basically what happens is this method is used when neither of the functions are in a good graphing or substitution form. Basically, meaning for substitution, then you don't have at least one equation that is solved for a variable, right? And the graphing is not going to be very nice as far as you're going to have a lot of fractions or decimals when you are going through and solving. So it's not a good graphing method and it's not a good substitution method. So we have another method called elimination. And you are going to basically you're getting rid of one variable by either addition or subtraction. Okay, so you're actually going to be either adding or subtracting the two equations together. This is a lot like polynomial addition and subtraction. And when we do that, we're actually going to get rid of one of our variables. So the goal is to always get down to one variable so that we can solve it. So we are going to add or subtract the two functions, again, like we did with polynomials. And the goal is that you either have to have your x's or your y's match so that when you add or subtract them, they cancel. They go away and make a zero pair. All right, so let's take a look at what this looks like and what it means, because otherwise it's very similar to substitution. You're going to solve and then you're going to substitute back in. Okay, so let's take a look at this function, this system. 3x minus 4y equals negative 8. 3x plus 5y equals 10. Okay, so notice my x's match. They have the same coefficient, right? So I can make that a zero pair if I subtract. Okay, now here's the catch. If you are subtracting, then you are subtracting each pair of terms that matches. Again, think of this like polynomial subtraction. You group your like terms together and then you are going to subtract. So 3x minus 3x is a zero pair, so it is gone. You are subtracting negative 4y and positive 5y. So negative 4 minus 5 is negative 9y. Like terms. And then negative 8 and 10 are constant terms. So we're going to subtract those. Negative 8 and 10 being subtracted is negative 18. And take a look, I don't have an x anymore. I'm down to one variable, which means I can actually solve this and then substitute back in to get the other variable. So this is how this works. You're either going to add or subtract. And I'll do examples of both just so you can see why it makes a difference if you're going to add or subtract. So I'm going to go ahead and solve for y and then keep going. So y is equal to 2. So I have half of my ordered pair. I need to substitute that back in. And again, it does not matter which one you substituted in. Take your pick, substitute it in, and solve. So I'm going to try the first one. Okay, so 3x, simplify that. Negative 8 equals negative 8. And to solve it, I need to add 8 to both sides. And I get 3x, zero pair, equals, oh, that's also a zero pair. So I have 3x is equal to 0, which means if I divide by 3, x should also equal 0. So my ordered pair, my solution is 0, 2. And again, neither one of these equations is solved for a variable. And if I were to graph these using x and y intercepts, I would get some pretty nasty decimals, and I don't want to have to graph those. It makes my graph really hard to read. So this is why this method actually works better. All right, so we've had one where we've done subtraction. Let's try one where we're going to do addition. Okay, so same thing. You're looking for a matching pair. Now, again, notice my y values have the same number, but their signs are different. Okay, so I can make my y's go away because I have a -2 and a +2. That's a 0 pair if I add them. So I'm going to do addition, and I'm going to do it for each set of like terms. So 5x plus 2x is 7x. +2 and -2 is a 0 pair, so it's gone. And then I have 22 and 6, which is 28. And again, one of my variables is now gone. I can solve for the other one. So divide by 7. I get x is equal to 4. Substitute 4 back in for x in either equation. And again, I'm just going to stick with the first one. 5 times 4 plus 2y equals 22. Simplify, that's going to be 20. And now I can go back and solve for y. So I'm going to subtract 20 from both sides, showing that I'm doing the same thing on both sides of an equation. That's the requirement. 2y is equal to 2. Divide by 2, and we get y is equal to 1. So my ordered pair solution is 4, 1. Okay, so you've seen one solved by subtraction, one solved by addition. And again, the biggest difference is here your numbers are the same, but they're not opposite signs. So in order to make the x's go away, I would have to subtract 3 minus 3. On this one, your numbers, your coefficients are the same, but their signs are opposite. So they're automatically in 0 pair if I add them. And that's how you tell the difference between if you're going to add them or subtract them. Now, I have a slight uplift from there as far as what the problem is with this problem, because this is a little bit harder. Please be really careful with problems like this. Take a look. They do need to be lined up. Okay, and there's a very specific reason that they need to be lined up in order to add or subtract them. Your signs could change if they're not lined up correctly. So the top one has 4y equals 2x plus 10. The bottom one has 3x minus 4y equals -9. Now, I could move the 3x on the bottom, or I could move the 2x on the top, and it does not matter which one I do. I'm going to go ahead, since the first one's already set up like this, I'm going to go ahead and move the 3x on the bottom one. I'm going to rewrite the equation. And in order to move anything across an equals, right, it's just like doing an inverse. You got to change the sign to use an inverse operation. So I'm going to subtract 3x from both sides. And this is a lot like doing literal equations where you're not actually getting a number answer, you're getting a new function. So 3x minus 3x is 0. That's gone. So what I have is -4y equals, and notice -9 minus 3x would still not be in the right position. I need to shift that around. -3x minus 9. So what I'm going to do is I'm going to ignore my original equation. I don't need that one anymore because they have to be written in the same order. So now I should be able to go through and they're lined up. I have the y and then the equals and then the x and then the number. This is good. So I'm now going to decide if I have to add or subtract. So I have matching numbers on my y's with opposite signs. So that's already a 0 pair. All I have to do is add them. So I'm going to go through and add all my like terms. So 4y and -4y is gone. So that's just 0, and make sure you keep that 0 there. Okay, and then I have 2x and -3x. So 2 and -3 is -1x. And then I have 10 and -9 that I'm adding, and that's a 1. So I need to go ahead and finish this equation. It's not done. I have to actually get x by itself. So I'm actually going to subtract 1 from both sides to get rid of the 1 over here. So I have -1 is equal to -1x. And then I'm going to divide both sides by -1. And I'm going to get 1 equals x, or x equals 1. Same thing. So then go back and substitute the x back into one of your original functions. And again, the reason I like crossing that out is because I can now use either of my original function or the new one, and it works. So I'm going to go back up to the top again. So x equals 1. So I'm going to substitute that in. Times 1 plus 10. So 4y, 2 times 1 is 2, plus 10 is 12. So 4y equals 12. That means y is equal to 3. So my ordered pair solution is 1, 3. Now that's what happens when your equations do not line up. So that is one of the first things you need to check for, and make sure they're lined up, and then check to see which of my variables are going to match. Now, I have another what if situation. If they match, all you have to do is add or subtract. What if they don't match? What if you do not have a variable pair that matches? It's actually not that bad. You can make a matching pair, okay? But the specific rule is you can only make a matching pair using multiplication, okay? And you have to multiply all the terms in your equation, right? But you can make a matching pair. You can make one of your variables, the x's or the y's, have the same number, have the same coefficient. So let's take a look on how we do this. Okay, so are my equations lined up? Yes, the first is the x, the second is the y, the last is the number. They both are lined up, so we're good, but the problem is my coefficient on my x's don't match, and neither does the coefficient on my y's. So I have to multiply one or both of the equations to get the variables, to get the coefficients to match. So I have a couple of choices on how I can do this. I could multiply the second equation by 2. If I do that, then my x's would match. You can also go through and multiply the first equation by 2 and the last one by 5, right? Because then your y's would both be 10s. You can do either way. I'm going to start with just multiplying the bottom one by 2. And I have to multiply all terms in that equation. So it's a distributive property problem that you're doing. So that becomes 2x plus 4y equals 14. And just like I did on the last problem where they didn't line up, I'm now going to cross off that equation because it's not there anymore. It doesn't exist. I've rewritten it as something else. So now I have to decide if I'm going to add or subtract. I now have a matching pair of x's, 2x and 2x. If I add them together, it's going to get 4. I need them to go away since they match. So I'm going to subtract all my like pairs. So 2x minus 2x is gone. That's a 0 pair. Negative 5 and 4, if I subtract them, I get negative 9. And then negative 4 and 14, if I subtract those, I get negative 18. Okay, so then continue to solve. I'm going to get y is equal to positive 2. And then I'm going to substitute my y into one of my two equations. So 2x minus 5 times 2 equals negative 4. I'm going to go ahead and simplify that and solve. So 2x minus 10 equals negative 4. I need to add 10 to both sides. And again, you could have divided by 2 on both sides. Again, you got to make sure you're dividing all your pieces, right? You have to do the same to everything. So 2x, 0 pair equals 6. And that means that x is equal to 3. So my ordered pair solution is 3, 2. All right, so let's try another one. Okay, so first thing to check, do my x's and my y's and my constants line up? Yes, they do. X first, then y, then number, we're good. But again, I have no matches, so I have to figure out how I can get them to be the same number. So I'm not going to be able to only multiply one function this time. So I'm going to have to multiply both to get them to work. Now, if I want my x's to match, I can multiply the first equation by negative 3 and the bottom one by 2. Basically, I'm just swapping the coefficients and multiplying by them to get them to be the same number. And they'll both end up as a 6. If I do my y's, I multiply the first one by 4 and the second one by 3, and then both of those would be 12, and those would match. So it does not matter which way you do this. I'm going to go ahead with my x's. I'm going to multiply this one by negative 3, and this one by 2. Again, I am just swapping my coefficients to multiply by. So my new first equation becomes negative 6x minus 9y, don't forget you're distributing a negative, equals negative 27. Okay, my second new equation becomes negative 6x plus 8y equals negative 10. Excuse me. So I'm done. I've rewritten them. So again, I get rid of my original equations. They're not going to help me anymore. So let's go through and actually solve it. So do I need to add or subtract in this case? Well, my x's match, same number, right? They're also the same symbol. What would happen if I added negative 6 and negative 6? I'd get negative 12. So I can't add them. I have to subtract. So negative 6 minus negative 6 is gone. That is a 0 pair. I'm subtracting negative 9 and 8 should give me negative 17 y's. And if I'm subtracting negative 27 and negative 10, I should also get negative 17. Right? Remember, because negative 27 minus negative 10, if you have a double negative, you are supposed to be adding. Again, if you're struggling with this a little bit, make sure you're grabbing your calculator. Okay, and then I'm going to divide by negative 17 on both sides, and I get y is equal to 1. Okay, so I'm going to substitute y into one of my two new equations. So I'm going to go with the first one. 9 times 1, negative 27. Simplify it. That's just negative 9. And then go through and actually solve. So in this case, I don't want to divide by 6. I'm not going to get nice numbers if I do. So I'm going to go ahead and add 9 first. So I have my 0 pair, that's gone. And negative 27 plus 9 is negative 18. Yeah. And then I'm going to divide by negative 6. And I'm going to get 3. So again, my solution for this one, ordered pair, x goes first and then the y. Okay, that's it. So 2 cases. You're either going to have ones that match or not, which means you have to make them match if they don't. And then you have to decide if you're going to add or subtract. And always make sure to check that they're lined up first. And now we are done solving systems.